Welcome back to my channel. Here we are going to work on this object. We are going to produce is oblique cabinet projections. As we have worked on it, we have produced the isometric projection of this object. So we want to produce the oblique cabinet projections. All dimensions are given in millimeters, and then as I said, these views are given in third angle projection. See, this is the front elevation, this is the plan, and this is the end elevation. So let's see how this can be worked out. So I believe you know the dimensions as I stated, the dimensions on the isometric projection. So when we are using the cabinet projection method, it means that the length of the receding line will be divided by 2. So the receding line is the length of the receding line is 80 millimeters. So if you divide 80 millimeters by 2, we have 40 millimeters. So, and don't forget that we are also using a 45 degrees set square for this particular drawing. So we are going to draw a horizontal line here, and then so with my 45 degrees set square, so I'm going to draw a line. I'm going to draw the receding line. So it goes in this direction. So it goes in this direction like this, and then so here I will draw a vertical line. I will draw a vertical line at this point like this. So on this vertical line, I'm going to take a measurement of 10 millimeters here. Okay, then here I will take 40 millimeters. So 40 millimeters, this is 40 millimeters. So at this point, I'm going to draw a vertical line. So then I'm going to transfer this for this 10 millimeters to here. Then okay, so then at this point I'm going to transfer this point. I'm going to draw it. So I draw it backward like this, and at the same time I will also draw this goes in this direction. So I'm going to take a measurement of okay, so this is the receding line. So we are going to divide it by 2, and that is going to okay, I will take 40 first. So instead of 80, we have 40 millimeters here. So this is 40 millimeters. So that's total length. Okay, that's total length. And then where we have 35 millimeters by 2, so that's going to give us 17. So I'll just take it as 18 millimeters. I'll just take it as 18 millimeters. 18 millimeters. So I have it at this point. So I'm going to transfer this. So I'll transfer this to this side. And this. Okay. So at this point, I'm going to erect a vertical line. At this point here also I will erect a vertical line at this point. Okay, so then I need to bring this line down. So I need to bring it down. So from this point I will take a measurement of 35 millimeters. So apart from the receding line that we divide into 2, because we are drawing it in oblique projection, so every other lines so retains its normal dimension. So let's take note of that. So and then so the next thing I'm going to do so is that at this point I'm going to draw a vertical line. So like this. Then I'm going to transfer this. So I transfer this one to this side. And I'll also transfer this. So draw it in this direction. So then instead of 10 that we took for isometric, we are going to take 5. So because this is still receding line, so I will take 5 millimeters here. So and then I will come here and take 5 millimeters. So 5 millimeters. So and then coming on this line, I will take 10. Here I will take 10 millimeters. So then I will transfer this. So this goes backward. Then so here I will draw a horizontal line to meet this line, and at this point also I will draw horizontal line to meet this line, and at this point I will draw horizontal line to meet this line. Okay, so then at this point I'm going to draw a vertical line like this. Also I will draw a vertical line here like this. Okay, then at this point I will also draw a vertical line to meet this. Then so at this point I'm going to draw a line that goes in like this. Okay, alright, so then the next that I'm going to do here is that I want to draw the the oblique circle on this surface. So I'm going to create oblique circle on this surface. So this surface is inclined at an angle 45 degrees. So we are not going to it's not going to be a normal circle. It's not going to be a normal circle. So so this is what I'm going to do. So this is what I'm going to do. So let's get the center first. So I will divide. Okay, so the circle is going to be reduced in dimension. So we have it being diameter is 20 millimeters. So in this case now, so the diameter becomes 10. So that means the radius becomes 5. So take note of that. So let's look at the center. So the center, so here we have what? Here we have, this is 20. So it will be 20 on this one. So here in the oblique isometric it was 15. So we are going to make it, let's make it 8 millimeters. So we just 8 millimeters. So it is half that we are taking. So we take it as 8 millimeters. So I'll just take 8 millimeters. So this is 8 millimeters. So here I will transfer this point. I transfer it to this side as a center line. Then, so for this, so I will take this. So it goes like this. Alright, so then, so the diameter, the radius becomes 5. So it is 5 that I will take. So I will take 5 millimeters to this side, and then so 5 millimeters here. So I want to create an oblique square. So here I will also take 5 millimeters to this side and 5 millimeters to this side. So so at this point now I will draw a horizontal line like this. Here also I will draw horizontal line like this. And then so for this, so with my 45 degrees set square, so I will draw a line like this. At this point I will also draw a line. Don't forget that we are using cabinet method of oblique projection. So for this now I can't use my compass to draw this, so I will just use my hand to bring out the circle because this thing is small. And then alright, so this is how the circle so will look. So the next thing I'm going to do here is to thicken the outlines edges or outline edges. Okay. Okay. Alright, so I'm going to pause the video and do the rest. Alright, so this is the oblique cabinet projection of the objects. As simple as I've done it here, all you need to do is to practice. Thank you and God bless you.